Hello, this is the second of 4 videos where we're going to go through a sample ACT. If you missed the first one, you might want to go back and look at this. But welcome to all my Bishop Garrigan students and to anyone who happened to randomly find this online. We'll be starting this video with question number 16. A car accelerated from 88 feet per second to 220 feet per second in exactly 3 seconds. Assuming the acceleration was constant, what was the car's acceleration in feet per second from 88 to 220? We have some choices of 1/44, 29 1/3, 44, 75 1/3, and 102 2/3. So if you look at the calculator screenshot, what I did here is I subtracted 220 minus 88. I looked at the change in feet per second. And then I divided by 3 because it took 3 seconds to make that change. It tells us we're trying to find feet per second. That second per means divide. So I took the change in feet per second and divided by the seconds. We get 44, which is h. So number 17 says, in a plane, the distinct lines AB and CD intersect at A, where A is between C and D. Then it says the measure of angle BAC is 47 degrees. What's the measure of angle BAD? And it might be 43, 47, 94, 133, or 137 degrees. So I drew a picture of this one. It tells us in the problem that A is between C and D, and these two lines intersect at A. And so if you look at the picture, I drew the two things that it tells us in the directions here. It also says that the measure of angle BAC, remember the middle letter is always the vertex, that angle has to end up being 47 degrees. We're supposed to find BAD, which in the way I drew the picture is just the other half of the bottom. Key thing is there's 180 degrees in a line, so we subtract from 180, the answer is 133. Next up, it says, in which of the following are 1/2, 5/6, and 5/8 arranged in order? And you can see we have those fractions written in basically every possible order you could come up with. Now this is another one you could do a bunch of ways. I would bet that whoever wrote this problem probably thought you were going to find like common denominators and work things out that way. But here, all you really have to do is think what decimal is each of those fractions. And you do that by just doing 1 divided by 2, 5 divided by 6, and 5 divided by 8 on your calculator. You can see we get 0.5, 0.83 with the 3 repeating, and 0.625. We're supposed to arrange those in order from smallest to largest. Well, that would be 0.5 first, then the one that has 0.6 and some change, and then the one that has 0.8 and some change. And that's why it's going to go 1/2 first, then 5/8, then we're going to have 5/6 last, and so it's got to be F. Question 19 deals with scientific notation, and it says, in scientific notation, 670 million plus 700 million equals what? And we have 1.37 times 10 to the negative 9th, 1.37 times 10 to the 7th, 1.37 times 10 to the 8th, 1.37 times 10 to the 9th, and finally 137 times 10 to the 15th. Now, before I do anything with this problem, I'm going to point out two answers that I absolutely know are wrong. First off, A is wrong because it has a negative exponent. In scientific notation, negative exponents mean you have decimals. These are big numbers, not decimals, so it's not A. The other one I know for a fact without doing anything is wrong is E. And that's because scientific notation always has one number, a decimal point, and then whatever is left for the argument, the first number in the scientific notation. 137 is not standard form for scientific notation, and that's why E is wrong. So we're going to focus in on the middle three and figure out which is right. And here I just added up the two numbers on my calculator and I hit equals, and now what I've got to remember is that what the exponent in scientific notation means is how many places there are after that first number, after the 1 in 1.37. So if I count, I go through after the 1, I count the 3 and the 7 and then the zeros, and it turns out there's a total of 9 places. That's why it's 1.37 times 10 to the 9th, which is D. The wrong answer people often do is they'll end up just counting the zeros, which would give you B, but again, it's how many total places there are after the 1. And now we have, for trapezoid ABCD shown below, AB is parallel to DC. The measures of the interior angles are distinct, and the measure of angle D is x degrees. It says, what's the measure of angle A in terms of x? It might be 180 minus x, 180 minus 0.5x, 180 plus 0.5x, 180 plus x, or x. All of those might be possibilities. And this really is one where there's only one answer that makes any sense at all, and that ends up being F. The reason why we subtract from 180 is when you have parallel lines, what we call same side or consecutive interior angles are supplementary. They add up to 180. So you go along a side, they've got to add up to 180. And it does turn out that 180 minus x is right. None of the others really makes any sense at all. It would be possible if it was an isosceles trapezoid that angle C would be x, but angle A sure isn't going to be. So question 21. To get a driver's license, an applicant must pass a written test and a driving test. Past records show that 80% of applicants pass the written test, and 60% of those who have passed the written test pass the driving test. Based on figures, how many applicants in the random group of 1,000 applicants would you expect to get driver's licenses? And it could be 200, 480, 600, 750, or 800. So there are two things in this problem that basically are giveaways on what we got to do. And, like passing a driver's test and a written test, means times. What's more, when you're dealing with percents, of means times also, like 80% of the 60% pass. And so this is going to be a multiplication problem, and what I do is I take 80% times 60%, or 0.8 times 0.6 times 1,000. That gives you 480, and that's the answer. 22 says if a, b, and c are positive integers such that a to the b equals x and c to the b equals y, then xy equals what? And it could be a times c to the b, ac to the 2b, the quantity ac to the b, the quantity ac to the 2b, or the quantity ac to the b squared power. So we're supposed to figure out what xy equals. And since x is a to the b and y is c to the b, xy is going to be a to the b times c to the b. Now, when I have two things to the same power, I could put those together and then take that product to the power. That's why we get AC to the B, which happens to be choice H. Number 23 says, which of these is equivalent to 1/2 y squared times the quantity 6x plus 2y plus 12x minus 2y? And you can see a whole bunch of possible answers. And so basically what we've got to do is multiply this out, see what we get. The first thing I did is I simplified what's inside of the parentheses. 2y minus 2y, those cancel. And I combined my like terms of 6x plus 12x, and I ended up getting 18x. So I've got 1/2 y squared times 18x. Now I take half of 18 is 9. I put my variables together, and what I have is 9y squared x. I go back and I look at my choices, and it turns out that choice A is the same thing, except that the variables are in alphabetical order instead of the order I wrote them down in. Normally, books and tests will write answers in alphabetical order, but it really doesn't matter which order you do, but A is going to be the correct answer. So here we have an artist makes a profit of 500p minus p squared dollars from selling p paintings. What's the fewest number of paintings the artist can sell to make a profit of at least $60,000? And it might be 100, 150, 200, 300, or 600 possible paintings. So there are multiple ways that you could do this problem, and I'm going to actually show you two of those. First off, what I think the person that wrote this problem probably intended was that you're going to solve this by factoring. I set the formula equal to 60,000. I got all my variables and numbers on one side, and now to factor, I have to find out numbers I can multiply to get 60,000 that are going to add up to negative 500. I end up getting p minus 200, p minus 300. The possible answers would be 200 or 300. The smaller of those is 200, and so that would be the answer. Now, I know most of the students I teach hate factoring and honestly aren't real good at it. And so there's some other ways you could do this too. It gives you the formula for what the profit is, and all you really need to do is start plugging in numbers until you get an answer that's at least 60,000. If I plug in 100 and I take 500 times 100 minus 100 squared, I get 40,000. So obviously not big enough. I plug in 150, I get 52,500. Still not quite big enough, but honestly, if I'm in a hurry, it might be enough to convince me that the next one's probably going to be the answer. And in fact, if I plug in 200, 500 times 200 minus 200 squared, I get exactly 60,000. That's at least 60,000, so that's our answer. Something to keep in mind is that when they give you a formula, you can always plug in the answers and see which one works. And if you have a clue of which places to start, that can actually be a pretty quick and efficient way of finding the answer. So question 25. Last month, Lucy had total expenditures of $900. The pie chart below breaks down these expenditures by category. The category in which Lucy's expenditures were greatest is what percentage of her total expenditures to the nearest 1%. And the choices are 24, 28, 32, 34, or 39%. So a couple of quick things before we officially find the answer here. The question says the category in which her expenditures were greatest is what percent of the total. Well, the greatest category is clothes. And if I just look at that circle graph, it looks to me like close are somewhere around a fourth. Maybe a little bit more than a fourth, but I know it's not going to be like 39 or 34 or really even 32% because it's not a third, it's closer to a fourth. And so already I know it's got to either be A or B. What I officially do on this is I figure out what's the total expenditures, which it turns out is 900 bucks, and I take 254 for clothes out of 900. I get about 0.28, and so it's 28%. That's going to be our answer. So this is another one to realize that they're not going to intentionally draw that graph wrong. If clothes look like they're somewhere around a fourth, it's probably going to either be A or B, and you can automatically eliminate the rest of the answers. Number 26, I redrew the figure that originally came with the sample test. That's because in the one that was originally there, I had written in some extra information that I want to wait to show you. So it says here in the figure, the measure of angle BAC is x plus 20, and the measure of angle BAD is 90, which of course you can see with the little square and the right angle marker. The question is, what is the measure of angle CAD? And we have x minus 70, 70 minus x, 70 plus x, 160 minus x, and 160 plus x. So here's the picture I actually scanned from the original sample test. And you can see I wrote in there x plus 20 in the angle they told us was x plus 20. What we want to do is take 90 minus that to figure out how big the other part of that right angle's got to be. And here I've got 90. I distribute the minus sign, so minus x minus 20. What we end up doing when I combine like terms is 70 minus x. So this one I also wrote some stuff on the drawing from the sample test, but I chose to go ahead and leave that in here. It says, what's the perimeter in inches of the isosceles triangle shown below, whose hypotenuse is 8 square root of 2 inches long? And we've got a whole bunch of possible choices here. Now, it tells us this is an isosceles triangle, and that means that we have two angles that have to be the same, and since I know one of the angles is 90, the other two have to each be 45. So it's a 45, 45, 90 triangle. They tell us that the hypotenuse, the longest side, has to be 8 times the square root of 2, so I went ahead and I labeled that in this picture also. And we're supposed to figure out if the perimeter, the total distance around, is 8, 8 plus 8 square root of 2, 8 plus 16 square root of 2, 16, or 16 plus 8 square root of 2. So this is a topic I don't directly teach in my classes, and it makes sense if kids from Garrigan get kind of confused about this one. There'll be people from other schools that look at this and they're going to immediately know that the answer is E, which it is. But I will point out a couple of other things that are useful to know. We know it's an isosceles triangle, so I know that the left and right-hand sides have to be the same. And I also know that those sides have to be less than the hypotenuse. The hypotenuse is 8 square root of 2. And so it's got to be something that's less than that. It turns out that how long those sides are is 8. They're the same, and if you actually work out the Pythagorean theorem, 8 squared plus 8 squared is going to end up being the square root of 168, which simplifies down to 8 square root of 2. So once I know that those sides are 8, I just add up 8 plus 8 plus 8 square root of 2. And when you look at your choices, the only possibility is going to end up being E. And next up is number 28. The equation y equals ax squared plus bx plus c is graphed in the standard xy coordinate plane below for real values of a, b, and c. When y equals 0, which of the following best describes the solutions for x? And we have various possibilities here. It says there's two distinct positive real solutions. There's two distinct negative real solutions. There's one positive and one negative solution. There's two real solutions that are not distinct, or there are two distinct solutions that are not real. So a lot of the ACT, the content is based around advanced algebra. And that's exactly what this question is. It's an advanced algebra question. We have a quadratic equation and we have a parabola that we're supposed to look at. Here they talk about positive and negative and real solutions here. Well, the solutions, or the roots, mean the places where the graph touches the x-axis. That's what we're looking at when we want to know solutions to a quadratic equation. You could also find that from the fact that they're telling you that y equals 0. Y equals 0 on the x-axis. So we're looking at what's going on when I'm at the x-axis. So in this problem, the parabola touches the x-axis once on the left, which was negative, and again on the right, which is positive. So we have a negative answer, we have a positive answer. That's exactly what H is saying, and that's the correct answer to the question. If it were two distinct positive solutions, you'd have a thinner parabola where everything was over on the right-hand side. If it was two distinct negatives, everything would be over on the left-hand side. If I went down to K, where it said not real, that would be a parabola that never touched the x-axis at all. It would like all be down at the bottom, the way this one's drawn. And two real solutions that are not distinct, that actually doesn't really make any sense, because if they were not distinct, they'd be the same and there'd just be one answer. But here the answer is indeed going to be H, one negative on the left, one positive on the right. So having just talked about non-real solutions, we have a question that deals with non-real or complex numbers here. The question says, what is the product of the complex numbers negative 3i plus 4 and 3i plus 4? And it could be 1, 7, 25, negative 7 plus 24i, or 7 plus 24i. Now, if you haven't done anything with complex numbers, this problem is going to look absolutely impossible. And in fact, the point of the question is really to see, have you taken high school classes that deal with complex numbers? Something I will point out is that they really did not write these numbers in what we would call standard form. Normally, you would write these with the real part first and then the imaginary part, and you'd call these 4 minus 3i and 4 plus 3i. And then it's a little bit easier to see that those are conjugates and that the i's are going to cancel out when you multiply them, which is why I know for a fact the answer won't be D or E. However, even if you have completely forgotten or you never did encounter how complex numbers work, this is where your calculator can come in and shine. Because on a graphing calculator, you can put I on the calculator as a complex number by hitting second and the decimal point. If I want to do negative 3i plus 4, I type negative 3. Then I do second decimal point to put I on there, and I put plus 4. And so I just literally typed in this problem on my calculator. Now, I do need to know that product means times. That's what we're doing, is multiplying these two numbers. And so I put negative 3i plus 4 times 3i plus 4. And you can see that it tells me the answer is 25 plus 0i. Some calculators will put the 0i, some won't, but either way, 0i is just 0, and that part cancels out. That's why my overall answer is 25, or C. And now we come to number 30, which is the last question in part 2 of these series of videos. And it says the radius of the base of the right circular cone shown below is 5 inches, and the height of the cone is 7 inches. Solving which of the following equations gives the measure theta of the angle formed by the slant height of the cone and a radius? And we have choices of tangent of theta equals 5/7, tangent equals 7/5, sine is 5/7, sine is 7/5, or cosine is 7/5. So a couple of quick things. First of all, don't get all worried about the fact that they're using theta. Greek letter just means angle when you see that in a situation like this. This is a trig problem, but it just boils down to what everybody calls SOHCAHTOA, the fractions that you put together with sides of a triangle in order to get the different trig functions. And that means nobody cares that this is a cone. You can ignore everything on the left and the bottom and just focus on the triangle. And it's either sine, cosine, or tangent of that angle equals some fraction. Now I'm going to point out that I know for a fact that 2 of the answers are impossible. And that's J and K. And that's because sine and cosine never can be more than 1. And so I know that it won't be either of those. So SOHCAHTOA means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. In this problem, if I look at the angle that's marked, 7 is the side that is opposite that, and 5 is the leg, the shorter side, that is adjacent to it. So what I know is opposite over adjacent. And I know opposite 7, I know adjacent is 5, so the tangent has to be 7 over 5, and that's why it's G. So we're halfway through the sample ACT now. Hopefully this has been helpful to those that are working with it, and if it is useful, hopefully the other parts will help you to prepare as well.